All right, ladies and gentlemen, so we are back, and in this video, I'm going to teach you how to solve a geometry problem that incorporates quadratics. So let's tell you what you're given in this problem. Let's get it written down. You are given that the area, you're given that the area of a triangle, okay, the area of the triangle is equal to 120 inches square. Okay. So I like to draw a little triangle shape. Don't have any idea if these dimensions make sense, but it really doesn't matter at this point. We're told that the height of the triangle is 4 less than twice the base. Okay, 4 less than twice the base. So if the base is x, the height is 4 less than twice the base. 4 less than twice the base. Okay? So remember that the area of a triangle is base times height divided by 2. So let's just do it. You know, this is the base, this is the height. We're going to multiply them together and divide by 2. So down here, I guess I'll do it over here so it kind of stays in the picture. We'll multiply the base of x times the height. Okay, 2x minus 4. And that's divided by 2. And all of that is equal to 120 inches square. So this is equal to 120. Okay, so we can get rid of this 2 by multiplying the entire equation by 2. And those will cancel on the left, leaving us with x, open parentheses, 2x minus 4, close parentheses, equal to 240. All right, so now I distribute the x. I get 2x squared minus 4x equals 240. Okay, we have to factor this quadratic, and I'll factor it using completing the square, since that's kind of the thing that I'm trying to teach students. Let me, if I could, move over here a little bit. So let me move over here and do that factoring. I've got 2x squared minus 4x, big space, equal to 240. Okay, first thing I'm going to do is get rid of this leading coefficient of 2 by dividing the entire equation by 2. And so now I have x squared minus 2x, big space, equal to 120. Okay, so now I take half the middle coefficient and square it. Well, what's half the middle coefficient? We have negative 2 over 1. If I multiply that by 1/2, I get negative 2 over 2, which is just negative 1. Okay, so now I square that term, and I get 1. So I'm now going to add 1 to both sides. Okay, so on the left, we'll leave it alone for just a second, but 120 plus 1 is 121, which we know is 11 squared, and that'll become pertinent here in a moment. On the left side, I know that I can write this as a perfect square binomial. X, and I'm going to come over here and look right there, minus 1 squared. Okay, that's the beauty of completing the square. I really love it. Now to get x by itself, we just take the square root of both sides. And here we're a little bit easier because we're not having to work with a fraction. On the left side, the square root cancels out the squared term, and I just get x minus 1 equal to plus or minus the square root of 121, which is 11. Remember that right term, when you do this square root, that'll always be a perfect square. It'll never not be a perfect square with completing the square. It's a beautiful method. I don't know if it was invented by this guy named Cardano, but I have this this book, and in this book written by Euler, okay, Leonard Euler, it's called The Elements of Algebra. It goes into great depth about completing the square. It's a really fascinating book, a little bit dense. I think I could spend the rest of my life reading it and still not get through it all. We just add add 1 to both sides. I don't know where I wrote 2. Add 1 to both sides. Okay. And now I have x by itself equal to 1 plus or minus 11. Okay, so x, we have 2x solutions. The first x solution is 1 plus 11. And the second x solution is 1 minus 11. 1 plus 11 is 12. 1 minus 11 is negative 10. Now we only want to use the positive solution because we're dealing with geometry, which has length and dimension, and we don't have a dimension that is negative. So we throw out and discard this solution, and we take this solution. So now why would we need that? We want to know what the base and the height are. So if the base is x, we can write base equals 12 because x is 12. Okay, so the height, H-E-I-G-H-T, is equal to 4 less than twice the base. So we do 2, open parentheses, 12, close parentheses, minus 4. All right, so just work this out. That's 24 minus 4, and that gives you 20. Okay, so here's your base. And here is your height. Let's verify that we did this correctly. Okay, so base times height divided by 2 should equal 120. Let's see if it does. Base is 12 times height of 20 all over 2. Okay, so 12 times 20 is 240 divided by 2. All right, and that equals 120. Okay, so check, we got it right. So that was how you apply quadratics to a simple geometry problem that involves area. So that's kind of a nice challenging problem. I really love problems like this. I've got one coming up that involves a cylinder. Really interesting, where we find the volume of a cylinder using quadratics. So look forward to that. But for now, I hope this was of some benefit to you. Thanks for your attention. Bye.